we are looking at a 5,000 share order.
Hey everyone, I'm Adedeji, and welcome back to Google Cloud Live. If you tuned into our last episode, you saw Greg, Luke, and Joe host an awesome session showing off agent skills for the Gemini CLI. We had some great live demos there, so if you missed it, definitely check out the recording. But today, we're shifting gears. Our theme today is multimodal agents. We're going to be building a system that can see, hear, and analyze data to solve a massive problem. And I'm super excited because I'm not going to be doing this alone. I'm joined by my awesome co-host, Wang. Annie, welcome to the stream. How are you doing?
Oh, hi, Io. I'm doing great. I'm so excited to start building today. You know, multimodal agent is such a good topic that actually start coding with everyone is going to be so much fun.
Absolutely. And, speaking of the chat, quick hi to everyone joining us across YouTube, Twitch, X, and LinkedIn. Let me see what we have here. We have a few people that have joined us. I see some from Canada, some from the US. That's great. But that said, let's kind of switch over to what we're going to be talking about today. So let me set the stage. For today, we're going to be going back through an interactive workshop called Way Back Home. The setting is you are a space explorer that got caught in a solar storm. You crash landed on an unknown planet, and your objective is to get back home, safe and sound, and also collect a few survivors along the way. And to do that, you're going to progress from simple prompts all the way to real-time multimodal systems. So you're going to learn multi-turn image generation with Gemini, learn how to build a multi-agent architecture with something like Google ADK. And there's multiple other levels as well, but for today, we're just going to be covering levels 0 and 1. So this is kind of the breakdown. So we're spending about 10 minutes on identity, kind of identifying ourselves with the rescue network. And then level 1 will be creating a multi-agent architecture that will help us locate ourselves on this unknown planet. So that said, to do so, you're going to have to walk through a code lab with us. And if you want to follow along, you're going to have to redeem some credits. So Annie's going to walk you through the redemption process on how you can redeem credits so you can use it as part of your Google Cloud project so you can go along with the lab with us. Annie, can you walk them through the process?
Yeah, sure. Yeah, so everyone, if you see the link on the screen, making sure you type that link, and then you will open up the page. Don't worry if you miss the link. I think we have TA in the chat to help you pin this link to you. So once you type this link, you will see a page look like this. And to just give you an overview of what this page is. So this is our workshop page for today. And at the very top is there's some instruction to do the setup. You have to, there are instructions on how to claim the credit, how to do the environment setup. And over here, we have an event code, hands-on AI. You might need this later on. So on top, on over here, we have level 1, level 0, and level 1. So those are 2 labs we're gonna work through today. And I'm gonna do level 0, I'm gonna work through level 1. And at the very bottom, you can see I have a virtual TA. So if you click the link, you will open virtual TA, and you can ask any questions about setup or any questions about the lab. So I'm gonna start by setup instruction over here. So for the setup instruction, making sure you're using the Gmail account, personal Gmail account. If you happen to use a corporate account or a school manager account, it will not work to claim the credits. And it's recommended to use an incognito window in case you have some account conflicts. All right, so next step is let's claim the free credits. To claim the credits, what you need to do is you simply copy this link. As you can see, I'm copying this link, and I'm opening a new tab, and I'm gonna paste it. So, and then you will see a page look like this, and it says hands-on AI Way Back Home live stream, and making sure you sign in the Gmail account, not the like organizational account or anything else. And let's get started to claim the credit. So once you click the link, you will look like you will see something like this, and I will accept and continue. And you will see credit successfully applied. If you happen to see something like, oh, put your payment information, you can ignore that, because to redeem the credit, you do not need to put any personal payment information. So if you saw, credit successfully applied, that means you successfully claim Google Cloud credits. And I'll go back to this instructional page. So now we finished step 1. Let's go to step 2, environment setup. So what we need to do right now is we want to have an environment set up so that we can do all our lab for today. And we're going to use Google Cloud Console. We're going to use Cloud Shell in Google Cloud Console. To open it, I'm going to copy this link, console.cloud.google.com. Like you copy this link, and you go to the same window. You will redeem the credit before, and you open. So I'm going to paste this console.cloud.google.com. I'm going to share this tab instead. So once you copy this, you go to this link, you will see Google Cloud Console. It will look like this, right? So what's next is you want to open Activate Cloud Shell. So to activate it, on the top right, there's a button look like terminal. So you click into that, activate Cloud Shell. So once you click that, you will see you have successfully activated Cloud Shell terminal. So this look similar, like very similar to VS Code, but it's on cloud. All right, I'm gonna clear this. Right. Okay. So what you need to do is go back to the go to this instructional page. Right? So now you open the terminal, and what you need to do is you copy this whole command, and then you just paste to the terminal. So right now I'm copied it, and I'm going to go back to the Google Cloud Console terminal, and I just paste it, and making sure right now you're at this root, right? So I just paste, and that's all you need to do for today's setup. Okay, if you find you're missing anything, feel free to ask TA in the chat, or we have virtual TA. You can, if you go to this page, at the very bottom, we have virtual TA. So you can also ask virtual TA any question if you run into any error during the setup. And don't worry if you feel like, if you find it, you're not catching up, but we have TA help you, so don't worry. I'm going to share this page. So Io, let's explain what this script does.
Oh yeah, sure. So so far what we've done so far is redeem credits for our Google Cloud project. So essentially, we want you to follow along with the lab with us, but you don't have to worry about linking any of your credit cards. So these are free credits. You can use them even after the session is finished. And then all we're doing here by running the script is essentially linking the billing credits with the project that we are auto creating. So essentially, you're going to have a way back home project in your environment with billing credits assigned, and then you're off to the races for level 0 and 1.
Yeah. So once you successfully complete the script, you will create a new project account. A project for you is called way back home. You will have something called way back home dash something to start. And then this project will link to the billing you just claimed. So if you see a yellow font look like this, that means you have successfully set up for today's workshop. All right, I'm going to pass it to you, Io, to explain level 0.
Absolutely. Let's go. Okay, so jumping into level 0, essentially our first step of this lab is we have to identify ourselves with the rescue API. The rescue AI says that it can't rescue us unless it knows who we are. So to kind of identify ourselves, we're going to be creating an avatar, an icon, and a username for our Space Explorer. So essentially, we're identifying ourselves with the rescue AI. And along the way, we're going to learn multi-turn image generation with Gemini, so kind of stay put. But let's kind of just walk through the lab to start off. So far, what we've done so far is Annie just walked us through the first step, preparing our environment. So we've redeemed credits. We've activated Cloud Shell. We ran that command to link the billing credits to our project. So now let's continue with the lab. Moving forward, we just want to make sure that within Cloud Shell, we're authenticated. So I'll just walk you through that right now. So most of you should be seeing something that looks like this, a kind of a blank Google Cloud console. To activate the Google Cloud Shell, again, you want to go to the top right corner and see this Activate Cloud Shell icon. I'm going to click it here. And it's going to open up the terminal. So I have my terminal here. I have my previous linking outputs. I'm just going to clear the terminal so it's a little bit cleaner, and I'm going to zoom in. The next thing we want to do is just do gcloud, and I'm just going to copy directly from the CodeLab. And again, for any of you who are looking for this link, please go to that hands-on AI-live. link that was put in the chat. That will show you where to find the lab. Right now we're on level 0, so we'll just go ahead and authenticate. So gcloud auth list. So most of you should, if you're authenticated, you should see active star and then the name of your account. If you don't see this, you can do gcloud auth login to authenticate in your terminal, but most of you should not be seeing that. But if you don't see an active account, just run this account to command to authenticate, and then that's pretty much it.
Or you ask virtual TA.
Or you can ask virtual TA.
Yeah.
Yeah. Then from there, all we're going to do as part of the lab is we're now going to do git clone against the way back home repo. So for these labs, we don't want you to have to worry about, building everything from scratch. So we provide starter files that have like, scaffolding code. So essentially you provide, the code to interact with Gemini, but you don't have to worry about importing some of the packages and things like that. So that's all we're cloning right here. And then now that we've cloned the repo, we're just going to do UV sync and CD into level 0. Since we're part of level 0 today, right now, we're going to move over to level 1 later on, but we're just going to CD into the level 0 folder, and then we're going to UV sync to kind of download all the packages that we're going to be using.
Oh, Io, did you clone the repo?
I did clone the repo. So
I didn't see your console. Can you please?
Oh, sorry. Yeah,
Okay.
so I ran git clone, provided the name of the repo. It cloned in about 5 seconds.
Yeah.
And if I do ls, I can see the outputs directly here. And also, as Annie mentioned, there's also an editor that comes with the Cloud Shell. So it's kind of like your built-in VS Code for the Google Cloud Console. If we also want to take a look at the outputs of what was downloaded, we can do that as well.
Yeah.
So I'm going to come over here to the way back home folder. As you can see, we downloaded all the folders for level 0, level 1, and some of the, again, the scaffolding scripts that we're going to be using just to kind of seed our projects with everything that we need. So yeah, everything looks great.
Io, I think you might need to clone the way back home in the root folder, right?
Oh, great point. So
Yeah.
it's great that I made that error. So a lot of times people kind of clone directly in the hands-on AI credit folder. You want to actually make sure that you are cloning in the the root folder for your project. So if you want to go to the root folder, do cd tilde, or you can do cd $, home, and that will make sure that you are in the root folder.
Yeah.
And then I'm going to go ahead and clone one more time, but I'm also going to make sure that I just delete that way back home folder because it's not needed.
Yeah.
I'm going to go back to my home folder, cd tilde, and I'm going to run that git clone command one more time.
Yeah,
And
for
again,
those of
go ahead, Annie.
Yeah, so for those of you who are watching, like usually it doesn't matter where you clone it, but it just we have some certain script that it has to run from a certain path. So that's why how we clone it matters, right? But usually it doesn't matter.
Yeah. And it looks like it's a little bit slower this time, but we'll give it a few more seconds. And also this will give people following along some time to catch up.
Yeah.
And one thing I can do to actually speed this up. So what is happening is when you're using Cloud Shell, you're essentially working with a remote VM that's hosted by Google. Sometimes if you download more files than you need, it can slow things down. So I'm just going to make sure that I've removed all unnecessary files like the cache and try one more time. And it should be a lot quicker. Yeah, so perfect.
Wow.
Yeah, great. Okay, so as I was mentioning, so pretty much all we've just done is download all the starter files and templates that we're going to be using for these labs. Now what we want to do is run UV sync within the CD level 0 folder. This makes sure that we're in the right folder for the level, and then we're just going to be downloading all the packages with UV, such as Google Gen AI for interacting with Gemini. And again, make sure that you are in level 0.
Don't forget to share your terminal, Io.
Oh yeah, great. So now that I'm here, I'm going to cd way back home, cd level 0, and then run UV sync. So it's going to be downloading Google Gen AI for interacting with Gemini, things like Pillow for image processing. We're going to be generating output avatars and icons later on in this level. And then we're going to be processing the outputs with, Pillow package, which is essentially imaging processing package, Google Auth for authenticating with APIs and so on. So these are just the packages that we're downloading for the level. Now that we've done that, we're pretty much good to go. But just to verify that, the last step of this step of the lab is just to verify our setup. It's going to make sure that we're authenticated. It's going to make sure that we have installed all the packages that we should have. So it's a pretty quick setup script. And yeah, ready to proceed. Okay, so let's go ahead and move to the next step of the lab.
Yeah, so we have successfully prepared our environment and we're ready to go.
Yeah, so the next step of the lab, we're going to be connecting with mission control. So as mentioned, we're lost on this uncharted planet. Mission control has no idea where we are, but essentially we have to identify ourselves. So as part of this step, we're going to be creating our avatar username, and we're going to be putting in the event code for the lab, just so we know we're all on the same planet. There's unknown planets, but essentially the unknown planet is kind of associated with an event code. So I'll show you that in a second. Let's see. Okay, so coming back over here, I'm going to go ahead and run the setup script. It's going to make sure that I'm authenticated. It's going to enable required APIs like Vertex API for interacting with Gemini. Then it's going to ask me for the event code. For those of you that are following along, make sure that you do hands-on AI.
Yeah, so the code is also on the instruction page, like I showed you at the very beginning. Yes. So we have a hands-on AI code on that page.
Yeah. And then for my lab, I'm going to say that my username is going to be Astro.io. I've seen pretty unique ones. Some people like to be Superman, Batman. Feel free to be creative here. So that's my Explorer name. And then so far what's just happened, I got a unique Explorer ID and then some starting coordinates that are randomly generated on this unknown planet. And as we proceed through the levels, we're going to figure out exactly where we are and let the mission control know where we are by building a multi-agent system.
Yeah. What do you think we show our audience, our planet first?
Oh, sure. Yeah. So here's our planet that we're going to essentially end up on. But let me go to that tab. So for now, let's see where everyone is. Okay, no one's completed it yet, but here's the planet. So it's an unknown planet. Mission control has no idea where we are on this planet. As we complete this level, essentially, we're going to see our avatar show up directly on it. Okay, it looks like one person.
Oh, one person. Let's see. Who is the person?
Celestial Caballero.
Wow, you're the first one.
Exactly. So that's a really good example of the output. As we complete this level, it's a pretty quick level, but essentially you're going to have your own avatar. You're gonna show up on the planet, and that's pretty much it.
Oh.
Okay, so let's go back to the lab. Level 0. So far what we've done again is we created the event code or specified it, and we've created our username. If you just want to double check that everything was put in correctly, you can CD back to the CD level 0 folder. And then you can do cat. And so this is what you should see as a general output. You should see the event code, which should be hands-on AI, your username, which will be unique to you, your participant ID, which will be unique to you, some starting coordinates, which again will be unique to you, and overall just the way back home configuration. The project ID will be unique to you as well.
Yeah, and this link is how we open that mission control. If you go
exactly. So if you want to go to that link, it's wayback-home-dev. And then you can just put in the event code to kind of navigate to that specific planet and see where everyone else is as well. So coming back over here to the tab, so let's actually go ahead and customize our Explorer. So for this next step, essentially, we're going to be providing all the prompts ahead of time that we're going to feed to Gemini. And the reason why we're doing this is because some people have restrictions in their projects that kind of limit direct image upload. So you may be wondering, things like Gemini, they can process images directly. So why are we providing text prompts as references for our customization? You can technically do both, but again, to kind of be more general and kind of allow other people to complete the lab, we're just going to be doing text prompts. If you don't have any restrictions and you want to create a photo-based avatar, go to step 8, and you can kind of walk through the instructions, and we'll show you how to, as opposed to text-based descriptions, upload an image of yourself, for example, and create an avatar that looks directly like your image. But that said, let's just proceed with a text-based approach. And I'm going to go ahead and run this next command here. So going here, uv run python customize.py. I'm going to say I want my suit color to be,
red.
So I'm going to say 2, and then I'll just give a short description of myself.
Maybe you should have a cat hat. What do you think?
I'll give a cat hat.
Like a astronaut's cat hat.
And I'll say wearing.
Friendly smile. Okay.
Wearing a cat hat. So again, these are text-based prompts that we're creating ahead of time that we're going to dynamically insert into our prompts that we feed into Gemini later on. So overall, it just saved. And again, if you want to confirm that everything saved as you wanted to, You can just take a look at the config file one more time. That's where we're saving these, preferences that we're going to feed to Gemini. So I can see that my suit color was saved, crimson red with gold trim. My appearance was also saved, and that's pretty much it. So that's it for this step of the lab. Moving on, now the fun part that you've all been waiting for, actually interacting with Gemini. We're going to be editing a generator.py file where we're going to be creating an actual API call and chat session with Gemini API. But before we jump into that, it's also probably necessary to kind of get some background context on what we're building and what we're interacting with behind the scenes. So that said, let me show you a few slides. So again, we're here in level 0, identity. It's a quick lab, so we're almost done. And then we're going to start building agents later on. But as we know, Google has a pretty broad AI stack going all the way from AI infrastructure, TPUs and GPUs, to data, BigQuery agents, to models, which we're interacting with as part of this lab, to a broader AI platform. So here's like a 10-yard view of Vertex AI in general. Again, we have the data cloud. We have things such as security command center for monitoring and logging agentic interactions. You can deploy your agent to things such as Agent Engine for managed deployment. And again, we have a whole host of models, such as from Gemini to third-party models, such as Claude, to open models, such as Gemma, that you can interact with directly from Vertex AI. But overall, for this level, we're just going to be working with generative media models. So let's also take a step back and think about what generative media models, means in context of this lab. As we all know, the transformer architecture, which was released in the Attention is All You Need paper back in 2017, kind of kickstarted the Gen AI revolution that we are in today. It kind of formalized the process for how you can take input embeddings based off of text prompts, do things such as multi-head attention, and then generate, realistic outputs that essentially predict the next words in the sequence. Multimodal LLMs are no different. The only difference is rather than just creating embeddings off of text inputs, you can also take embeddings off of things like video and audio inputs. You encode them all into the same embedding space, and then you have the same encoder decoder architecture, and then you have a multimodal generator such as Stable Diffusion for generating images, or Zero Scope for videos, or Audio LDM for audio generation. But overall, this is kind of like the architecture for a multimodal LLM for multimodal understanding as well as multimodal generation. And as mentioned before, all you're really doing in these scenarios is you're encoding visual tokens and text tokens to the same embedding space. You have the same encoder decoder language that was kind of first formalized in the transformer architecture back in 2017. And then you're just predicting the next token, whether it be the next pixel of the image or the next kind of audio second of the audio, if it's an audio LLM, and so on. So that said, that brings us to where we are today with models such as Nano Banana 2 that was released earlier this month. You can generate, a wide variety of images from, 1080 to 4K resolution. It's really great at adhering to text-to-image prompts. So why are we using Nano Banana 2 as part of this lab? Or actually, we're using Nano Banana. It's extremely great at text-to-image fidelity. So you can give it a text prompt, and it very closely follows your instructions and generates an image that kind of aligns with that text prompt. Also for things like image editing, Nano Banana is extremely great at that. And as you can see in popular online benchmarks such as El Marina, it's highly rated for great reason. And moving on, here's kind of just like a general kind of definition scope of what you can do with these models. You can process input PDF, text, and image, various aspect ratio outputs from 1:1 to 16:9 to square outputs to different fidelity resolutions. And kind of breaking this down on what you really can do, you can do element preservation. You can provide up to 14 image inputs and output like a very realistic image that synthesizes all these various image inputs that you're providing. And this is really great for ads, marketing, and retail. When it comes to something like style consistency, you can provide various images that essentially give it a prompt and say, I want this to kind of be adhered to from a style standpoint. It's extremely good at generating multiple images that kind of adhere to that style. Also generating text across different languages. Again, think about ads, marketing, retail use cases. As we talked about aspect ratios, it can generate horizontal, portrait, 1:1 images, and so on. It's very good at one prompt storyboard. So what that means is you provide one singular prompt and you can generate multiple images that align with that particular prompt. So it's not just one prompt, one text output, or one prompt, one image output. You can generate multiple images with one input prompt. So we call that the storyboard feature. and it also has real world knowledge. So essentially it's powered by things like grounding with Google search. You can give it kind of a building in a different country and say, generate an image that looks like that. It would use grounding behind the scenes to kind of get reference images and actually generate something that's aligned with that actual building. So it's, also powerful in generating, images that are aligned with real world context. And sorry, my screen moved on. And the reason why we're talking about this all at the end of the day is that with these workflows, with these models, you can power really powerful applications. And a really good example of that would be something like Figma that has integrated this into their image editor. You can have an image, say, change perspective of the cake, for example, to a bird's eye view, and it changes it using the power of Nano Banana. So again, at the end of the day, while we're learning very simple code, 10 lines of code, you can interact with Gemini. Really behind the scenes, this powers really powerful applications that you can then use for different use cases. So that said, let's go ahead and now edit the generator.py file. So I'm going to go ahead and move over to the lab again. So again, this is where we are, Cloud Shell edit generator.py. I'm going to go ahead and copy that here.
Yeah, so this will open the editor.
Exactly. So this is going to open the editor and take us directly to the file that we talked about earlier on. So this is the VS Code editor.
Editor we
talked about earlier.
Remember to share the right screen.
Yeah,
yes.
Thank you.
Thank you.
So what I just ran was Cloud Shell edit generator.py. And this will take you directly to the file in the editor. If you don't want to do that, you can just open the editor directly and navigate to the file. But this is just an easier approach. So what you're going to see in this file is 3 different placeholders. There's one for creating a chat session, one for generating a portrait, and one for generating an icon. So first step that we want to do is actually create the chat session. So let's go ahead to the lab again and kind of see the next steps of the lab. So when it comes to creating a chat session, it's very simple. It's chat equals clients.chats.create. We're going to specify the model. So we want to interact with Gemini 2.5 Flash image or Nano Banana. You just specify the model ID. Again, if you're going to interact with Gemini Nano Banana Pro would be a different model ID, or Nano Banana 2, you just find it in the documentation, put the model ID, and that's pretty much the only difference that you would kind of specify for different models. And then lastly, what we're going to specify is response modalities, text and image. Pretty much all we're configuring here is that we want the model to generate both text and image outputs. So that's just an important thing. If we just put text, it's not going to generate the image. So that's just one thing to keep in mind. So I'm going to go ahead and create this chat session and go over here back to the editor. And I'm going to paste this here. And make sure that you follow the indents. You want it to be aligned with like the general other indentations. Oftentimes people kind of make a mistake where they kind of have the indentation kind of misaligned. So just make sure that you're paying attention to how the code is indented. So that's pretty much it. And one other thing to keep in mind with this client chats.create command, you're also kind of authenticating with a global endpoint behind the scenes with this command right here. So I'm going to go ahead and save it. And now going back to the lab, the next step of the lab is to actually prompt it with our portrait prompt. So if you recall in the previous steps of the labs, what we did was actually create our appearance and username ahead of time. So now all we're going to do is pull from the config.json. So if you go to the actual code, you will see at the very top that what we're doing is we're reading in that config.json file that we created earlier, and then we're going to dynamically insert those details such as the appearance, username, directly into the prompt for Gemini. So that's pretty much all we're doing. So again, we created a file. We're pulling details from that file. And sorry, my screen is going a little. And then we're going to essentially then save those as variables and then dynamically insert those variables into the prompt. So let's take a look at the prompt that we're creating for the portrait. Create a stylized Space Explorer portrait. Character appearance, we're using Python syntax for inserting the appearance that we specified earlier. Name on suit patch, again, we're specifying the username, suit color, and we're giving it some critical style requirements. Again, digital illustration style. We want everyone to kind of look the same, pure solid white background, aspect ratio, 3/4 view, and so on. And again, Gemini is extremely good at adhering to these text-based prompts. So that's pretty much all we're doing is we're creating a text prompt, then we're feeding it to the model using chat send message, and then we're generating a portrait response, and then we're going to parse out the image from that response, again, using some logic, and then we're going to save that portrait image as part of an outputs folder. So that's pretty much all we're doing here in this lab. So I'm going to go ahead and copy this prompt here.
I really can't wait to see the generated icon.
Yeah. Yeah, so I'm going to go ahead and paste this here, and that's pretty much it for this second step of the file. So all we've done so far is create a chat session, and then now we're feeding a prompt to that chat session using a chat send message command. Then lastly, for this file, there's one other placeholder that we have to fill in, is creating an icon image. So if you recall, for Rescue AI to kind of know who we are, we have to create a portrait, an avatar, which we've done so far, username, as well as an icon. And what a lot of people do when they're interacting with these models is if they want to create two separate images, what they'll do is actually create two separate independent API calls to the model. And the issue with that is a lack of character consistency. So what you tend to see due to the inherent stochasticity of these models, if you call the model even with the same prompt, you may get avatars that look slightly different. What we always recommend as the best practice is you create a singular chat session, and then you pass multiple prompts within that chat session. So the model has shared context and memory of what is generated in the past. So it's one way of kind of unlocking character consistency when you're interacting with these Gemini models. So again, not independent API calls, you create one chat session, and then you pass multiple prompts within that chat session. So let's take a look at what we're doing here as part of the lab. So we created our portrait prompt, and then for the icon prompt, we're actually not going to provide any of those details. We're not re-specifying the aspect like appearance or the username. It's actually kind of already embedded as part of the model's memory of what it generated in the past. So all I'm going to say here is now create a circular map icon of the same character. I'm passing the same critical requirements, same person, same face, same expression. And again, I'm expecting the model to have memory of what it generated in the past. Background, pure solid white background. And that's pretty much it. And again, I'm sending the message within the same chat session that was created earlier. And then all I'm doing here is processing the output. So I'm going to go ahead and copy this code.
That's so cool that in the prompt you can say same person, same face to stay consistent in this generation.
The model has memory of what it generated in the past. So it's a really good way of maintaining consistency with your generated outputs. So I'm going to go here and copy this prompt. And here's the last step of this file. I'm going to scroll down to icon image, and I'm going to paste this here. Just make sure that my indentation is correct. And also, you may notice I'm pasting it below the placeholder. Feel free to actually just remove the placeholder, and it's the same thing. I just like to remember where the placeholders were, but I'll just go ahead and remove it. And again, we're just specifying the prompt for the icon, and that's pretty much it. So all we've done so far in this file is create a chat session, create two separate prompts, and we're passing it within that chat session to the model. So I'm going to go ahead and exit out, and it looks like my screen froze, so I'm just going to go ahead and refresh. Okay, great. So that's pretty much it. I'm going to make sure I save the file. I'm going to go back to the terminal and proceed with the very last step of the lab. So scrolling back here to the lab, we are now here at the generate register step. So you may notice, even though we edited the generator.py file, we're actually running the create identity file.
Hey,
the create identity file has a few more things.
Hey,
yeah, thanks for letting me know.
Okay, thanks.
So this is where we are in the lab, generate and register. So you may notice that we're running the create identity file rather than the generator file that we just edited. This create identity file is kind of like an all-in-one type of file that actually calls the generator file behind the scenes, and also does a few other things such as upload the generated assets to our mission control API and registers our username against the planet. But overall, behind the scenes, we're calling that same generator.py file that we just edited. So I'm going to go ahead and copy this command here and make sure that I'm zoomed in so you can see. And what you should see is creating identity for Astro IO or whatever your username is, generating your portrait.
Yeah, so this is using the logic we just
exactly. So it's creating a chat session behind the scenes with the Gemini Nano Banana model.
Yeah.
It's passing in the prompts. It's creating our portrait. It's generating our map icon, making sure that they're consistent. And then again, as mentioned before, the create identity is doing a few other things behind the scenes, such as uploading our assets to the mission database, registering our username with the rescue network, which is a Firebase kind of hosted API behind the scenes. And that's pretty much it. So I can go directly to the planet to see where I am.
I can't wait to see your cat hat.
Yeah, so, I can see that other people have completed the level with us so far. And I can see that I'm here, and this is my image. But if you want a kind of a clearer view of your outputs, remember we save this locally to the outputs folder. So I can kind of go back over here and go directly to the editor. I should go to the outputs folder within level 0, and I'll see two different image outputs. Here's icon.png. So again, I gave some details. I set a cat hat, and it generated something that was pretty consistent, as well as a portrait image. And you kind of see that they're both really similar. So the model was able to kind of modify the aspect ratio for the icon without kind of losing context of what it generated in the past. So that's pretty much it for level 0. So overall, what we've done so far is register ourselves with the mission control API. We're identified. We're now up to 24. That's pretty great. I see some pretty cool usernames: Superbot, Superdone, Astro Chris. Pretty nice, pretty creative. And that's pretty much it. So now moving on for level 1, what we're going to do is actually identify ourselves and locate ourselves on this planet using a multi-agent architecture that Annie's going to walk us through.
Cool. We have 27 Explorer already. Wow.
Yeah.
All right. So let me share my screen to continue explain level 1. Yeah. So what we just done is level 0. So if you're still in the middle of it, you can still continue doing this, or you can listen to level 1. You can choose how you can continue. So for those of you who want to continue with level 1, again, I'm at this page, the instruction page, and just click start level 1. Again, if you have any question along the lab, you can go to virtual TA to ask questions or type in the chat. So if I click this link, I'm clicking this, and it will open our level 1. And so for this level, by the end of it, you will not only learn how to generate like an image, video, you can also learn how to build a multi-agent system with different type of tooling, including fast MCP and Google Managed MCP server, and also faster and also function tool. So it's a lot of you can learn a lot by the end of this. Also, we touched a little bit A2A, right, IO?
Exactly. So when we deploy our multi-agent architecture, we're going to enable it with A2As for agent-to-agent communication. But again, Annie's going to walk us all through that.
Yeah,
so
sure.
Let's dive in.
Yeah. So for those of you who are already landing on this planet, it's amazing that now we have 32 Explorer. You know, like now you're landing on it. You want to know which part of the planet you're on, right? So let me share this tab. So you want to know your location. How do you know your location? And this is basically the flow we're trying to implement. There's a lot of things going on, but so we're going to come back to this picture by the end of our lab. Let's just start by first trying to figure out where we are. We want to generate some evidence, because right now you can take a look at this planet. You know, they have some distinct region, right? You have some critical, some volcanical, some fossilized. We have different type of, we have different type of biome on this planet. You want to know which part, where you are, so that you can eventually figure out the way back home, right? So our first step is trying to figure out where you are and trying to generate evidence to figure out where you are. And let's continue to the level 1. And again, let's start to set up the environment. For those of you who are watching right now, you do not have to set up the Google Cloud credit, because we already done this at the beginning. So you just need to continue run the script to set up the environment for level 1. I'm just copy this command, just like what we did for level 0. And I'm going to this Google Cloud console. I'm going to refresh the page in case it's expired. You might have to refresh the page if you building this together with us, because it might have it might time out, or it might have some terminal reauth issue if you're not refreshing. Again, so right now I have this editor. I will open the terminal. Okay, I'll open the terminal. Cool. So, okay. Yeah. So right now, the very first step is let's set up environment for level 1. I just copy the command. I copy the command from the instruction and paste in the terminal. And what it does is
all we're doing here, right, is we're installing APIs or enabling APIs and installing packages that are specific to level 1. So we ran through a setup step for level 0, but level 1 has its own APIs, such as interacting with MCP and so on. Is that correct?
Yeah. So exactly. we first verify the building account is successfully linked so that you have the building enabled. And then your enable related API, for example, like Vertex AI, Cloud Run, Cloud Build. So eventually you're able to deploy things to Cloud Run, deploy your MCP server, deploy your agent to Cloud Run.
Okay.
Yeah. And we have Google Cloud MCP server for MCP and setting up the service account.
And then we're going to go through all these details later on, but we're just enabling all the services ahead of time.
Yeah, exactly. Yeah, so IO, like we're trying to generate our evidence first, right? Do you think what kind of evidence we want to generate? So that
great question.
Like,
so
we
remember,
figure out eventually, we know.
Remember the scenarios, we crash landed on this planet. As Annie mentioned, there's 4 different biomes. There's a cryo, volcanic, bioluminescent, fossilized, and we don't really know where we are on this planet, but we're going to collect multimodal evidence of our surroundings to kind of figure out where we are. So imagine if you were lost anywhere, what you may do is take your phone, kind of record kind of the settings around you, kind of figure out where you are, take a picture. So pretty much it's kind of interactive.
Record.
Prompting Nano Banana and our Google's kind of frontier text-to-video model, VO 3.1. We're going to pass in details of our environment, and it's going to generate multimodal images and audio and videos of our surroundings that we're then going to create agents to kind of then process each of those kind of multimodal inputs. And then these agents are going to have their own consensus and help us determine where we are.
Yeah, so let's first generate those evidence, generate those image, generate those video. You're trying to gather this evidence first so that later on agent can analyze it and then tell you where you are, right? And so we just run the first command to do the setup. And let me share the tab to run. So if you finish setup, you will see the output look like this. All right, so once everything successfully set up, you see environment setup complete. And what's next is you need to source the environment variable. Again, I'm just copy this, and I'm going back to my terminal, and I paste it to the terminal. And you can see it's loading the project ID and also the participant ID. So this ID is you generate this ID. Remember, we generate this in level 0. All right, let's come back and install dependency. You may notice that we are using UV sync here. So basically, we are using UV to control all the dependency, and we have all the dependency installed, set up in the this is level 0. All right, level 1. Let me go to the we have all the dependency set up in this file. And if you run UV sync, you have installed some related dependency. And let's go back to the setup page. And now let's set up our star catalog in BigQuery. So let's set. So by running the script, you will set up all the star catalog, and then you will able to load all the related data in BigQuery, so that later on you can connect to BigQuery and analyzing data, and then tell where you are. So I'm gonna just copy this command uv run Python setup to set up our evidence, set up our information in BigQuery.
Yeah, and just to emphasize that point, as we were talking earlier, so we're lost, we're collecting evidence of our surroundings. Part of that evidence is actually structured data that we're storing in BigQuery. So it's not all just images, video. Part of the definition of multimodal is also structured. So being able to process, structured text inputs as well as image inputs. So to kind of simulate that, we're, creating star data of our surroundings, which we're storing in BigQuery. And then later on, we're going to actually use a managed BigQuery MCP server to connect to that BigQuery table and then analyze that structured data in real time.
Great. So now I am at console, Google Cloud Console. So if you go to console.cloud.google.com, you will open this Google Cloud Console. And I want to open BigQuery to take a look at what we just created, right? So when you open this page, so first of all, don't forget on the top left button, top left on this page, we have this project picker. So making sure it's picking the project, selecting the project you just created, which start with way back home. If it's selecting a different project, you might want to go to the All tab and then select the project you created for this project. So once it's selected, And now I'm at BigQuery, right? I search BigQuery. So now I'm at BigQuery in Google Cloud Console. I'm clicking into this. As you can see, that I have our way back home data, right? I'm trying to I'm gonna like open. So now, as I just mentioned, we create this table like star catalog, and we can see we have this primary star, like star color, biome information. And if you want
a preview of the table too.
Yeah, so if you want to see the information, I'm clicking this and I'm running this in the query, and oh, I guess I zoom in too much. Yeah, you can see that we have all those information. We have this blue giant, like red stopper, like red giant. We have all those information loaded. Like those are how we describe, this planet, right?
Yeah, exactly. Yeah.
Cool. So if you're able to see those information in BigQuery in Google Cloud Console, that means you successfully load all the information required, all the data required for our workshop for level 1. And I'm going to go back to the instruction page. So I finished setup. And what's next is, we want to generate those evidence, just like I will mention before, like we need to generate those image data, just like how you use a phone to take a picture, take a video of your surroundings. So we want to generate those evidence. We want to generate those image data, video data.
And video data too, yeah.
Exactly.
So behind the scenes, this generate evidence.py file, if anyone wants to take a closer look at it, essentially it's using the same patterns that we learned from level 0, creating a session with the Gemini model or the VO model, and generating images or generating video. So it's a great file to take a look at if you just want to kind of reinforce your understanding of how to prompt Gemini or even something like VO.
Yeah, so if you go to generate evidence file, so this is like we have some bio evidence, and then if you're interested in what is the logic behind, you can go to this profile like generate evidence. And if you for those of you who finished level 0, you might already you might already familiar with how to use Nara Banana to generate the image data, right? But here we also have like how do you generate video data information. Okay, so as you can see, it's trying to generate the video information.
And again, everyone has random coordinates, so each evidence may look different. So don't be surprised if yours doesn't look like Annie's. It's actually meant to kind of be again, you're prompting specific evidences of your environment, and you should get kind of different outputs as a result.
Yeah, as you can see that it's trying to generate a video right now, but it's already generated some image data. So let's take a look. Wow. So we have some like star field and the soil sample. Wait, just by this, I'm gonna guess it might add the IC part.
I see. Yeah, it looks like it.
Yeah.
Well, hopefully we can build the multi-agent system and kind of confirm that's exactly what we are.
So we want to build a multi-agent system to analyzing data from, let's take a look at the video. I'm not sure you can hear the sound.
Yeah.
Pretty cool. So we want to build an agent and tool to analyzing this video information, including the sound data, like like all the video image, and we want to also analyzing those image, trying to figure out where they are on this planet. So we want to like have multi-agent to a different agent, different tool to analyze in different way, and then eventually they want to vote. Like, okay, I vote for your like volcanic, I vote for your at IC area, and then like eventually they're gonna make agreements. Say, okay, most people agree on this region, and then that's how we're gonna analyze where they are, right?
Yeah.
So I'm gonna continue sharing this tab, and then let's start to build our tool to start analyzing the data. So right now I finished step 3, and I'm at step 4 right now. So to add step 4, first you need to open this file. So you need to go to level 1, MCP server, main.py. So I'm gonna go to this.
I guess, Annie, before we built the MCP server, can you explain exactly, what is MCP? How is it used in agent systems?
Yeah, for sure. Yeah, of course. I think that's a great question. So before we're building MCP server. This is a picture of like a agent agent part and MCP server part. As you can see, the agent part on the left-hand side can be MCP client, and on the right-hand side can be MCP server. So agent, just to recap, in case you're confused, everyone talk about agent, but what is agent? Agent, we have model as a brain to make a decision on what tool to use. To like, so it will select different tool to make a decision for you and do some action for you, right? And then for those tools, we are connecting to MCP server. So MCP server is like, MCP is a universal like a adapter to different type of tool. So by wrapping different tools to MCP server, it can connect into all different type of tools, all different type of agent, and even like you're on different cloud, different framework, as long as you have you're having the MCP server, it's like universal adapter so that it can connect into different type of agent, right? So right now we're trying to. So right now we want to create this MCP server over here and connecting to our agent. Oh, by the way, this is like a high-level picture of what we're gonna build right now. And right now we are at tooling layer. So it's a lot of things going on this diagram, and you can take a look from the bottom to top. And the bottom has a data layer, and we just finished the data layer, like BigQuery data. And you can see we navigate all this information in BigQuery Google Cloud Console. And next layer is tooling layer. So tooling layer that today in this lab, we're gonna learn how to build custom MCP server, MCP tools. And we're also gonna learn how to build Google Cloud Managed MCP server, and also function tooling. So so right now we are at this stage, trying to build a custom MCP tool so that we can eventually analyzing those information.
Okay, so it looks like we're creating specialized tools that our specialized agents are going to use.
Yeah.
This is kind of like a best practice. Okay. Yeah.
Cool. I'm gonna go back to my instruction, and so right now we are creating this geological analysis tool, trying to analyze some geological information. As you can see that we are using fast MCP to create MCP server. This is a custom MCP tool we are creating. And over here, this doc string actually matters, right, IO?
Exactly, yeah.
Yeah, so it's taking the image URL over here, and it's returning those description. So basically, it's analyzing the image data. And so for an agent connecting to the tool, it will read this doc string and gonna read, okay, this is what this tool does, and gonna decide whether to use this tool or how to use this tool, right? Okay, so what I'm gonna do is
and we're passing in. And can you explain why we're passing in the GCS URL rather than the image directly? Like, is this for efficiency?
Yeah, you can.
Yeah.
Oh yeah, so it's for efficiency, and also, so you're talking about why we're passing the image URL?
Yeah, so as opposed to kind of trying to pass in the image data, to the model. Yeah, you can imagine, for speed purposes, the Gemini model can work directly with the GCS URL.
Yeah.
So passing in the text string is better than trying to pass in, multiple bytes of image data, through like an HTTP call when interacting with an MCP server. And also, when it comes to like a multi-agent architecture with the ADK, which we're going to be building the system with, it could be difficult to pass multimodal data through delegated calls.
Yeah.
Yeah.
So even the model can take multimodal information. But when the agent, in terms of agent-to-agent communication and agent-to-tool communication, usually it's recommended to do the, you can pass with the URL in this way to efficiently communicate.
Yeah.
So I'm trying to find a geological tool, and I'm gonna go back to my. Okay, so I'm gonna first finding this replacement, and then I'm gonna so here, this is replacement. I'm gonna coming back to this. I copy this things I want to paste, and I'm pasting over here. As you can see, I'm creating this first MCP tool, analyze geological. So this tool is trying to analyze the image information. The image I just showed you early on, right? Those image information. Great. And next, we also want to create another MCP tool. So I'm going to this, okay, I'm going back to this page. I want to create a botanical analyze tool to analyzing video information over here. So again, you can see we have this annotation similar to the previous one, and we want to create another MCP server tool. And I'm going to share the screen. So what we just before is we create this MCP tool, like analyze serological tool. And now we want to create this analyze botanical tool. Okay, so I'm gonna, yeah.
Yeah, and pretty much all we're doing is adding the MCP decorator to the functions. So it's essentially fast MCP syntax for converting local Python functions into MCP compatible tools, right? Yeah.
Yeah, so you can see we have this annotation over here, and those are functions. So those docstring define the how we define the tools, and this is a implementation for it. So I'm gonna just replace. I'm gonna looking for replace botanical tool in this file, and copy this and paste. Cool. So I'm gonna coming back to this MCP server. So now we have successfully created 2 MCP server. We want to first test locally.
Wait, one MCP server, right? But with multiple tools. Yeah.
Yeah. Oh yeah, one MCP server with 2 tools. Thanks for correcting me. So I'm just copy this and paste. I'm gonna paste it to the terminal.
So why are we running it locally and not just deploying it directly?
Yeah, you don't want to just break a production, right? It's always a good practice to test or verify things are working before you deploy them.
Yeah, makes sense.
Because it costs money when you are hosting things and deploy. Yeah, as you can see now, we are able to see this MCP server, fast MCP server running on HTTP transport. And what's next is we want to deploy MCP server to Cloud Run. So I'm gonna end the process by Control-C and coming back to this tab. And next is deploy MCP server to Cloud Run. So to deploy, I also just copy this command, and I'm coming back to this terminal. I'm gonna paste it. And this is to deploy the MCP server we just created. And as you can see from this command we're running gcloud build submit, and it's using the cloud YAML file. So I can quickly show you the cloud YAML file we are using. So I'll yeah. Do you want to like quickly explain?
Yeah. So cloud build is essentially like the CI/CD engine behind most processes on Google Cloud. You can use it to automate multiple steps. So pretty much as you see here, even though we're running a single line as part of the copy paste of the lab,
single
really
line.
There's 3 things that are happening behind the scenes.
Yeah.
We're building the container image for the MCP server. So downloading all the packages, creating a container image essentially.
Yeah.
And then we're going to actually push the container image to what we call artifact registry. Artifact registry is essentially like our primary container repository on Google Cloud.
Yeah.
And once you have your hosted container image, you can then deploy it directly to Google Cloud Run, which is essentially like a very great service for microservices. Spins up, spins down. You can specify minimum number of instances, max number of instances. So that's pretty much all being automated behind this one cloud build YAML script.
Great. So I'm also going to show the Google Cloud Console, and I can say if I search like cloud build, it's going to see the process it's trying to building right now. So it's not a black box experience. You can go to cloud build and to see the current building process, and you're also going to see the if I zoom in it's too much. Maybe here it's easier to navigate. So you can see all the process, and you can see that which step it is at cloud build. And eventually, when it's deployed, you will able to see the tool MCP server that's deployed to Cloud Run. But right now, because it hadn't deployed yet, so you're not able to see it. But we were going to see it soon.
Yeah, and I see a few comments saying that it's taking them a few minutes, and that's expected because there's multiple steps. It should take you about 2 to 5 minutes for the entire build and deployment of the MCP server.
Yeah, so we have multiple steps here. All right, so now while we are waiting for this to run, I will continue to our next step to build the specialized agent. So I'm gonna share this screen. So I'm gonna waiting for step 4. There's a very end step. I'm gonna get to that later because it's gonna take like a couple minutes to deploy. So I'm gonna go to step 5, build a specialist agent. And so what we did before is we create the MCP tool, right? We create those analyzing video, analyze image tool, so that now we are deploying them to MCP server. What's next is we want to have the logic for geologic analyze and botanical analyzing with ADK, like agent development kit framework. All right. So let's get to this. And first, let's create this geological analyzed agent by going to this file first. So making sure go to agents, geological analyze file. So I'm copying this file and going back to this Cloud Shell environment. And I'm going to this file over here. As you can see, I have this replace placeholder. So I'm gonna come back and trying to copy this agent code. So let's take a look at this agent code together. We are creating this geological analyze agent, right? And then for the ADK agent, we have the name. So basically this name is the agent name. It's also very important that the name you put in here is also for how other agent understanding this agent. So it's not only for human readable name, it's also for agent to understanding what agent it is. And we're using this Flash model. I do think the description matters. Like, is it just for a human to read or?
Oh no, description absolutely matters. So when you have like a root agent that's coordinating multiple sub-agents as we're going to build, the description helps that root agent or coordinator agent determine, which agent should I call for a particular task. So you want to make sure that your description kind of is semantically aligned with what that agent is supposed to do. So if used as a sub-agent or an A2A protocol, other agents know what it's meant for.
Yeah, similarly to the name also matters, because if you point to this name, it's just a variable name, and this is actually the agent name, how an agent communicates. So other agent will, like, based on reading this description, they understand what the agent does and understand how to delegate, whether to delegate to this agent or not, right? Through A2A agent card, or like through agent to agent communication or agent deployment or more. I'm gonna copy this. And coming back to this tab and place it. As you can see, we are trying to connect the tool we just created over here. But later on, we were going to talk about how agent and tool connect to each other. And again, I'm going to this agent and going to replace the botanical agent. So similarly, like our geological agent is to analyze the soil sample, is an image analyzing, and our botanical analyzing is a video analyzing. You can see we have this recording URL here, right, Io? Like,
yeah, exactly.
Yeah, cool. So I'm gonna copy this and.
Yeah. Okay. No, for a second. We couldn't see.
By the way, I was sharing the wrong screen.
Yeah.
Oh, yeah. Okay, sure. So, okay, I'm going to the botanical agent. So over here. So this is the botanical agent. Oh, oops. Okay, I'm coming back. So here I'm coming back to the instruction. I'm copy the agent code, and I'm coming here and replace it. And you can see that we have this URL over here, right? So this is how agent gonna eventually read the video information. And also, just like I mentioned earlier, that we are not passing the whole like image or video data. Instead, we are using the URL to communicate more efficiently.
And when we say URL, we mean the GCS kind of URL. Yeah. Google Cloud Storage.
Yeah. So let's coming back to see what we just did. Like we have been creating the two agent. So let's coming back to this picture. So we just create this agent that's able to analyzing the image, and also able to analyzing the botanic, able to analyze the video information. And what's next is, what if we want to we want to have a tool that actually able to connect to BigQuery data and directly analyzing things from the BigQuery data. So we want to create another agent that's able to connect to our data layer. So here we want to using Google Managed MCP server to do that. let's take a look. Yeah, why don't you share more about like our Google Managed MCP server? How does that differ from MCP server we just created? Like, because we're like, you can do fast MCP, right? You can wrap everything. Why do we want to use this?
Exactly. Great question. I would say it comes down to developer velocity and essentially not having to rebuild the wheel. You can imagine multiple teams want to interact with BigQuery, and imagine if each team has to build their own custom MCP server for something like BigQuery. So what Google Cloud has done, in the past 2 months or so, is come up with what we call Google Cloud MCP servers. These are remote MCP servers that are hosted by Google. So essentially, all you have to do is authenticate against them, and then they come with kind of pre-baked tools. So like for something like BigQuery. You can list data sets or list tables or execute a query. But overall, essentially, these are managed MCP servers that are deployed by Google Cloud and managed by Google Cloud that all you have to do is authenticate and call them. So it's a lot different than having to kind of define your own MCP server as we did with the earlier Analyze geological. It's a lot less work overall.
So, imagine you have to customize. You have to if you have to create your own MCP server, you have to do all the logic and wrap with pass MCP, and you have to deploy to cloud and host it. But with Google Cloud Managed MCP, you can just directly use it, and that's a lot easier.
Yeah.
So now let's go to our astronomical.
Yeah, that's a mouthful. Yeah.
Okay, let's go to this. So I'll go to this another agent, and this agent, it will trying to connect to the BigQuery MCP server tool, and also we have a custom function to extract information, so that basically we have a helper function, custom tool, so that we can easily connect to BigQuery toolset, and we will get to that in a second. But first, let's put our agent. So I'm copying this code and sharing this window. Yeah, Io, you want to say something?
Yeah, but as you can see, we've now created 3 sub-agents that we're going to use as part of our workflow, and pretty much they all have the same pattern. If you scroll to the top of your screen, there's from Google ADK agents.import agent, so very simple import, and then you can specify your file, your tools, and then from there, as you mentioned earlier, you provide the name, the model, the description, and instructions to the agent, and as well as any tools that you want to provide. And again, so it's a pretty simple syntax as far as defining what your agent does. Yeah.
Exactly. So similar to other agent. All right. So we were talking about the Google managed MCP server, and also we talk about. So let's go back to this. So now we've been building those agents. We have this geological agent, we botanical agent, and astronomical agent, analyzing agent, and we have those tools, right? And then we just now we need to figure out a way to connect the MCP server to the client side, just like this, right? We want to making sure when agents loading all the available tool from MCP server and able to pick the tool on this MCP server. I'm gonna share this tab, and so add the tools, MCP tools.
So this is essentially just like the ADK syntax for connecting a remote MCP server and making it kind of accessible to an ADK agent, right? We're just essentially just defining that endpoint.
Yeah. So I'm adding this page tools at MCP tools, and over here I'm copy this code to replace MCP tool connection, over here. And you can see this is really important. We are having this streamable HTTP connection parameter, so that you are able to connect to the MCP endpoint on Cloud Run.
And that MCP endpoint is essentially that Cloud Run URL that also, just make sure that we don't forget, did you go back and save the export?
Yes, let's do it. So, all right. So this is actually in the step 4 after we deploy. So at step 4.
Make sure that you switch tabs. Yeah, sorry.
Oh, at step 4, build MCP server at the very bottom, have saved the URL. And this MCP server URL is a URL that referencing that code, right? Before I didn't run this command because I was waiting for the build deployment to finish. But now looks like it's already finished from the site, and we can quickly verify it on Cloud Run service, and you can see we have this deployed, and I will just copy this command and paste it to our terminal.
So we're just essentially making sure that the Cloud Run URL is available locally. Okay.
Yeah, so now if you have this arrow, I might want to refresh the page. Again, if you have that arrow, you can like ask a virtual TA to help or paste in the chat. I'm still waiting for it to load. Okay. All right, so once I refresh, I saw this yellow sign point to the right project. So this is very important. Sometimes when you refresh, you might not point to the right project. Depends on maybe you have a different project, like different window. Yeah, so over here, I'm exporting this MCP server URL and trying to set the MCP server URL here. For the specified region, I'll just do US Central 1. Okay, so now I'm having this MCP server URL over here. Great. I'm gonna continue to build this connection. So I'm gonna share the step. Previously, I was trying to connect the MCP tool to the server, and here we are having this MCP tool set, and URL is MCP endpoint, and we just export the endpoint, making sure we have this available, right? And next is star tool. So remember, going back to this whole big picture, we're connecting them, right? So once we deploy this MCP server, we are able to connect the agent to the MCP server. And we also have this cloud server, Google managed MCP server, but we need to have like a helper function or custom function so that we can better connect to the cloud managed MCP server. So here we have another tool that's a function tool, like custom tool over here.
Yeah, which makes sense because even though there's a Google managed MCP server, you still have to have helper function that authenticates against it, and so essentially that's what you're defining. Yeah.
Yeah. So we want to have this helper function over here to extract some star feature information so that we can better use this tool.
Yeah.
We're gonna share copy go over here. This is the step 6. I'm going to the tool. I'm gonna share this window. So first I'm making sure I'm at the right file, at the star tools file, and I'm coming back. So I'm copy this whole like function tool over here. Yeah, this looks, so we're creating the GenAI client, and those are basically local function tool, like logic. And by the very end, we're using function tool to wrap everything so that it's a custom like functional tool for ADK. As you can see, I have this replace star tool and finish. So what I just did is I create this extract star feature tool so that later on this agent is able to using both tools to analyzing my information to make a decision on where am I on this planet. Now I finished step 6, and the next step is we're trying to orchestrate everything to create a parallel analyzing, and then it's time to see this picture. To be able to create a parallel analyzing, first let's take a look at what workflow what are existing pattern we can use. So we have so ADK. Oh, sorry.
I'll make sure. Yes.
Oh, okay. Thanks.
No problem.
Thanks for reminding me, Io. Yeah, Io. What's your favorite workflow on this screen?
Yeah, I like workflow agents. It's a good way of deterministically kind of setting patterns for how your agents interact.
Yeah, what is your favorite one on the screen?
I would say my favorite is the parallel. I like to.
That's why you use
I like to
parallel
move
for this
fast,
one?
and I find that the parallel agent allows you to essentially have multiple agents running concurrently. So it's a good way of kind of doing multiple things at once.
Yeah. Yes, for those of you who are watching, we have different type of workflow. We have sequential workflow that running from the left to right. It's a fixed order. We have parallel that run in parallel. That's Io's favorite. That's why I will put the parallel agent in our lab today, right? Okay, not only that, also because it's a good case for parallel. We also have loop agent that run things in a loop. For example, if you want to make an agent that's design a trip and the trip budget, it has to be less than 100. So you can run it in a loop that until the budget is like less than 100, so that making sure the agent having the output that that's what you want. We also have this hierarchical pattern that we have this router gonna make a decision and delegate to a sub agent. We're also using this hierarchical pattern in this lab, right?
Yes. Yes, we are. But you know, the nice thing about our lab, there's only one kind of sub agent as far as the agent is concerned. One issue you tend to see sometimes with hierarchical patterns is that if you don't have a deterministic like sequential or parallel and you just allow a root agent or coordinator to kind of choose which agent, sometimes it doesn't choose the exact agent that you want.
Yeah, if you're using if you're using just the normal like hierarchical pattern, for example, we have sub agent 1, 2, 3. If it's a sequential agent, for sure run from 1, 2, 3 order, right? For the hierarchical pattern, you have 1, 2, 3 as a sub agent. It might not executing things like in this exact order, even though you want to have the prompt, have this order defined in the prompt. Great. So for this lab, we are using what it is. What is the pattern?
Essentially, a parallel agent with a root orchestrator.
Yeah. Great. So what we just did, we create this geological analyzing agent. And we have this botanical agent, we have this astronomical agent. So we want to run the analyze all at the same time, right? So once they make a decision, we have this 2 of 3 agreement, so that if 2 of them think, okay, I'm at a conical area, I'm gonna confirm this location, and I'm gonna say, okay, yes, you're at botanical area. If like 3 of 3 agree, that will be amazing. But yeah, it's basically like 3 agents run in parallel and they vote, and if majority agree,
so one agent may think that we're in the cryo region, 2 other agents may think that we're in the volcanic. As long as 2 out of 3 agents agree, based off of how we prompted the root orchestrator, it's going to call the confirm location tool to kind of lock in our location so that we can be rescued.
In this diagram, we also have the setup callback. So Io, would you mind explaining what are callback for?
Yeah, callbacks are a great way of kind of customizing behavior of your agentic workflows. You may want some sort of custom routine to be run before an agent gets called or after an agent gets called, or before a tool or after a tool, or before a model or after a model. Adedeji has this construction called callbacks that essentially allows you to specify when something gets run. So oftentimes you see people use it for logging. Whenever this agent gets called, I want to make sure I log the outputs to the database. And you can have like a callback that essentially executes each time after that agent gets called. Sometimes you want to kind of do something before. Let's say you don't want to kind of overuse your agents. So you may want to double check to make sure that everything's in place from like a data or inputs perspective before you actually call the agent, so you don't overuse tokens. So sometimes people use before agent callbacks to kind of make sure that all the inputs are kind of set as they're supposed to be. And that's actually what we're doing as part of this lab.
Yeah, we also I remember when we do the model armor, we also check it in a before agent callback so that you will check, you will block things before.
That's a great point. Yeah, the Google Cloud has a model armor, which is a good way of kind of protecting and filtering, malicious inputs and outputs from your model. So oftentimes people use model armor as part of a callback. So before something kind of gets back to the user, you may want to kind of have it checked and filtered. Yeah.
Cool. So I'm going to quickly go back. So here, what I'm going to do is I'm making sure I set up this callback so that they're loading the necessary information before the agent start, and then I'm going to orchestrate everything in the parallel agent. So that's what I'm going to do in step 7. I think making sure I'm sharing the right screen. Okay. So step 7, go to the agent and go to the file agent, and now I am at the right file. I need to first replace the parallel crew with the code below. As you can see, we have this parallel agent. You just need to have parallel and have all those things in the sub agent. So that's how you orchestrate. I put a whole you have this parallel workflow created. So let's copy this and go back to our code, and you have this replace parallel crew. So I'm gonna paste it over here. And here we have this callback logic so that later on we can use this callback in our root agent. So let's go back and to create a root orchestrator. So again, I need to find replace root orchestrator and replace the root orchestrator. So coming back to my code, here's replace the root orchestrator. And you can see the first, I have the sub agent that is evidence analyze crew. So this is like a hierarchical router, right? I have like one children only, like one sub agent only. So I just only delegate to this one agent. I cannot delegate to other agent.
Exactly. And then we also have the before agent callback.
Yeah.
That essentially is calling that custom logic to make sure that we're embedding the agent runtime with all the participant context that we created in level 0, your username, where is your evidence located. So whenever the root orchestrator gets called, we make sure that essentially all the details that it needs for the reasoning is available.
Yeah. So if you go to the setup participant context, you will see what are the callback logic we added over here. Great. Go back. We have orchestrated everything, and next is we need to confirm the tool, right? Because they need to make a decision. I need to have like 2 out of 3 agree, and once agree, most majority agent agree, we need to confirm the location. So first, let me go back to the code and let me go to the confirm tool, and
this confirm tool is essentially a function tool that's available to the agent that wraps an API call to our mission control. So as long as there's a consensus between the agents, essentially the root orchestrator can call this tool to essentially notify mission control that what our location is.
Yeah. So again, this is another function tool. Let's coming back to the high level picture we have. So now we are orchestrated. So we just create this root orchestrator, right? We orchestrate. So we first have this parallel agent, and then we put all the necessary agent here so that we create this parallel agent first, and then we put the parallel agent as a sub agent for this root orchestrator agent so that this agent can delegate to the parallel agent and run the analyzing in parallel. And once they all like analyzing, like they have this, or they have the result finished. So we are using this confirm location to synthesizing the result and then confirm the location thereon.
Yeah.
Great. So now we have everything finished. We have everything finished, and let's try to test it with ADK Web UI. So I'm going to start the ADK Web server by copying.
Annie, could you explain what ADK Web UI is?
Oh, sure. So ADK Web UI is a tool for you to directly interact with ADK agents. So like we're creating this, as you can see, we have this parallel agent, we have the root agent, right? So this ADK Web UI is a way that you can directly talk to the agent in the interface. And not only that, you can navigate to see the tracing. You can see what the tools are being used. You're able to see the session, the state, how do the agent manage state and pass to each other, and also you can evaluate agent in the ADK Web UI. So it's a very powerful tool for developer to directly interact troubleshooting with agent we created.
Oh, nice. Okay.
And let's copy this and paste it over here in the terminal. So first it's grabbing the participation ID and it's grabbing the MCP server. So that's making sure we are connecting the agents able to connect to the remote MCP server. And if you take a look at the command we are running, what really matters is ADK Web. UV run is making sure we are in the right environment. And ADK Web is all you need to open the ADK Web UI. So if it's successfully running, you should be able to see something like this. And let me go back to this. All right, so you can see we have this running. So you can either follow the step to change the port to preview, or you can directly click this link. You should be open to a new tab like this. And on the top left, you can select the agent you just created. And yeah, those are tracing event state that you can look into the detail. So I'm gonna go back to my lab and trying to ask a question. Like by copy this chat interface. So in the run analyze, I'm copy this test and go into my ADK web UI. I'm gonna paste the information and press it to see.
Yeah, so now we're interacting with the multi-agent system that we built. It's delegated to the parallel agent system. So we should see the geological analyst be activated, the botanical analyst, the astronomical analyst be activated. And as Andy mentioned, the ADK web UI is great for development. You can actually see all the traces of what's being called behind the scenes. And you can see all the features and tools that each agent has available to it, which we defined in the code. So let's see what these agents come up with.
Yeah. So you can see it's trying to using different agent to make a decision, and also this is a custom tool to try so that it can interact with the BigQuery we created earlier, and it's executing the SQL. This is the SQL that's interacting with the BigQuery and analyzing the geological. Okay.
So astronomical says we're in cryo. Okay, that's great. That based off the images, that's pretty correct.
Yeah. We have also
sometimes ADK web repeats itself, so you can kind of
yeah. Oh, okay. So we have geological also 98% confidence. It's a cryo. Also botanical analysis 95 confidence. Great. I think all three of them think we are at cryo.
Yeah.
And let's ask like where am I? So now because we have three agents trying to like make a decision together, right? Let's take a look at what is the final result. Okay, so excellent work, everyone, to analyze. So it will synthesize the result, and it will confirm the location and confirm this is your location. Great. So now you know where you are at the planet.
Yeah, so help is on the way. So the rescue team is on their way. And let's take a look at the planet. So for those of you that are following along, you should see now that you've now completed level 1, that your beacon is lit. So if we search for the search bar, or maybe you just enter it.
Search file.
Yeah. And also takes about 10 seconds for it to update, so you may have to refresh.
Wow. Yeah. I'll refresh it.
It says number 1 now. Okay, great.
Yeah, I can. Okay, let's see. I'm gonna refresh it to see how many people are level 1. Okay, we have Edu Explorer. Congratulations, you're at level 1. Gregor Palian. Congratulations. Yeah. All right, so we are almost run out of the time. Maybe it's time for us to wrap up and go to our question.
Yeah, so we can switch over to Q&A. For those of you that want to continue on with the lab, the last step of level 1 is you deploy that agent to Cloud Run with A2A enabled. So if you want to kind of get experience with A2A, please kind of go ahead and finish up the last step of the lab. And he mentioned, let's go over to the Q&A. So let's take a look at some of the questions that we received. Okay.
Okay. So
Sudeep asked from YouTube, can we integrate 2 agents into one just to reduce number and simplify task from one of them? What do you think, Annie?
Yeah, I think essentially it's a design choice to see how many agents you want to create it in the system. In this case, we want to have specialized agent because the single design principle that you want to have one agent responsible for one thing. But essentially, it's a design choice that the more agent you have, maybe the system is more complex, but you're adding more control to some workflow. Yeah, so theoretically, you can just only using one agent for everything in today's thing, but maybe not parallel. But you can just in the prompt say run those things in parallel. But if you're not having multi-agent to orchestrate everything, like have one specialized agent to one thing, it might not do exactly what you want. So it's essentially a trade-off and a design choice. Anything to add, Io?
No, exactly like you said. And also when it comes to an agent evaluation standpoint, sometimes if you give an agent too many instructions, yes, it kind of simplifies your workflow, but you tend to see kind of trade-offs where performance starts to kind of decrease because the agent has to kind of think more through its kind of disparate instructions, and oftentimes you have to give it more tools if you're giving it more instructions. So it's always better to have specialized agents, as Annie mentioned, just for a more focused workflow. Let's think. Okay, another question came in. I really like this one from Jumper Code. When building Gen AI apps for thousands of users, how should developers navigate the trade-off between cost, speed, and something like image fidelity?
What do you think?
That's a great question. Yeah, so it's like you have a multimodal application. It's supposed to generate images, and also I think this lab is a really good example of that, where you have to generate evidence, but we kind of purposely limited the video output to only 4 seconds, even though something like VO can output up to 8 seconds. So sometimes you kind of navigate kind of what is your purpose of your app. Can you get by with less token output? Do you really need 4K output of your images, or would something like 1080p work, or even 720? These are all kind of configurations you can have as part of the models. So it comes down to your use case, but you can always kind of toggle down as needed. And obviously, like as part of your app, have like a premium user versus basic user experience. So, yeah.
Yeah, we also have a great question that people, folks from YouTube, like Bug Tank, ask, what is the difference between MCP and skills? So in this lab, we're using different type of MCP. We're using fast MCP, we're using Google managed MCP, but we haven't using skill in this lab. But yeah, skill is a quite common, like quite popular recently. So I personally think that with MCP server MCP is mostly you're connecting to a tool, right? Like in this case, for example, you're connecting to BigQuery, and you're using BigQuery data, you're interacting with BigQuery data to make a decision, or you're using another tool to analyzing the image. But for skills, it's like you're writing. For example, if you have a skill, it's like you're writing. You have the skill that's good at maybe writing using ADK to write an agent, or you have a skill. It's like a playbook that you can.
Yeah, there's more context involved. Yeah.
Yeah, and also one thing is for the skills is you are not. It's like lazy loading. Like it's not like not activated. You will not consume context window if you're not activate the skill. If you're not using the skill. But I think that's something also good to know. Anything to add, Ayo?
No, you got it pretty well.
Oh, sure.
Yeah, so I think we're just past like the hour. So I guess we'll be wrapping up here. Thank you for following along with us. If you want to continue on with this lab series, while we went through levels 0 and 1 today, there's levels 2 through 5 that covers more of a multimodal live API experience. So you get to interact and build like a multimodal live streaming agent. So please kind of take a look at the links in the chat if you want to go through that.
Yeah.
But until next time, we'll be back next week. We're a different host, but thank you so much. And
yeah, also don't forget to leave any comments if you like this kind of workshop.
Yeah, we would love your feedback and let us know how we can improve or what you loved about the labs. And until next time, thank you so much.
Thank
I'm Ayo.
you. Bye. I'm Annie. Bye.
Yeah, bye.